Today's presentation about economics of LEDs in indoor application and the CO2 emission came from one particular inspiration. One day I have received an email or an advertisement which I'm sharing now. Okay, that's something which came on into my email, and here is an excellent deal of a luminary which is offered as a low price product. It's got a little bit of the description on the right side. So I begin to wonder and I begin to think whether this is actually a good deal or not a good deal, whether this product is actually economically attractive or not. And particularly when you analyze the parameters which are shown on the right side, you can very quickly figure out that L70 rating is actually achieved with 40,000 hours. So let's kind of look into what I concluded based on that particular inspiration. So if you look into this product, which I have just shown, with that particular degradation, within approximately 9 years of being used, so here is a plot showing you've got here the years of usage, and here is your effective luminous flux. You will be losing the performance, you will be losing the luminous flux from that particular luminary. Within 9 years, you will need to get a new one. You will need to pretty much replace this luminary because the aging is such a rapid factor. Okay, and then after 9th year, from the year number 10, again you will be using a brand new luminary. That was pretty much logic that I have thought of. Most of the LEDs luminaries got a bit higher, a very high initial output, and within certain time, the output from the luminary drops to the level that requires some action or some replacement. Normally, traditionally, people are looking at 50,000 hours to determine that end of the lifetime. And in other cases, you know, there are different approaches. Some people looking at 60,000 hours or even longer. So there are products on the market that I'm also going to look at. These are luminaries with drivers which allow a constant light output, or CLO driver. What it means, you know, these products will intentionally address that overpower area and will intentionally drop the power when the luminary is brand new, and gradually the power will be increased to compensate for that aging. So hopefully a straight line of the light lumen maintenance factor will be achieved. So we're also going to look into this in this presentation. So what I'm showing is that initial power is a little bit lower, intentionally lowered. The average is around 25 watts in the case of the product I have selected for study, and the final power is actually much higher. Okay. So can you really maintain it? Probably yes, but there are quite a few conditions obviously coming with warranty replacement, timer settings of these drivers. So when you're dealing with a luminary and it's got a CLO driver installed, what you've got, a brand new luminary's got intentionally lowered power, and over time, over years, the power is gradually being increased, so you can maintain the same lamp lumen maintenance factor. But imagine that you've got a catastrophic failure and you are about to replace a luminary, or keep the same luminary but replace the driver. So when you've got pretty much a new driver replaced in the luminary, which got already some history, again, a new driver will start probably climbing up from the very low power and gradually will be increasing that output. But as your LED chips are already a bit old, your output will be compromised. Okay, that's something that we'll need to think about. When you decide not to change the entire luminary, but just simply replace the driver, this is likely is going to happen in your product. We've got an extensive study of the CLO drivers and CLO techniques that we can share. Penny's got a copy of our internal publication delivered by ETAP, but I will be putting some of analysis later showing the CLO drivers. While I'm pointing into it, the CLO driver are relatively new to the market. They seem to be presented as a solution that saves a lot of power and making these products a bit more economical. But there are some issues, as I mentioned earlier, with driver replacements, which are a little bit worrying. Okay, our approach, however, the ETAP approach, focuses on a couple of critical parameters, traditional parameters, let's put it this way. One of them is Lamp Lumen Maintenance Factor, and the second is Luminary Maintenance Factor, okay? Lamp Lumen Maintenance Factor, it's a parameter which describes the output of the LED chip. Normally, it's determined at 50,000 hours. It's pretty much directly related to the temperature or heat being lost in a junction point of the LEDs and how well you can really handle that heat, how quickly can you remove. That pretty much affects your lamp lumen maintenance factor. But another parameter, which is extremely important, is the luminary maintenance factor, which comes with the luminary itself, with the fitting. Okay, somehow for many years, a lot of companies seem to be ignoring these critical parameters. However, we've done a lot of research in this area with partners, in European partners, including Zumtobel and Philips and Osram. You can see one of the statements that was already indicating that we had data and we had verified numbers related to the the luminary maintenance factor, okay? Where this is all coming from and how it was driven. Well, first of all, luminaries with LEDs got slightly different heat distribution, okay? Here, what I'm showing is on the left side is the cross-section of a fitting with fluorescent lamps. You can see these two fluorescent lamps, and you can expect air to circulate in sort of, you know, this particular pattern. On the right side, you've got a luminary with PCB with LED chips somewhere here, and heat is being transported from the fitting towards the backside, and it's pretty much lost into that cavity. On top of that, you need to be aware that in order to ignite fluorescent lamps, high voltage is required, around 2000 volts. And you end up producing constant static electricity, static charge on the LED tubes, sorry, on the tubes, on the fluorescent tubes, not the LED tubes. What it means that you're going to create static electricity which attracts dust. You get a lot of dust built on glass tubes of fluorescent lamps. That used to be a significant problem. But this problem pretty much disappears when we are using LEDs, okay? There is nothing really which produces static electricity, so you don't get the effect of dust being attracted to static electricity, okay? That's a big, very big difference. So for a long time, ETAP's been testing these values. Luminary maintenance factor. What this is actually is like contradicting with research being done by some other companies. So here is a screenshot from 1680 standards. there is a table, well-known table, which describes typical values of the maintenance factors. And it's all pretty much, if you can read it, you can see that still you got bare lamps. It's all related to the IP rating. IP rating, you know, it's a parameter which describes really how well is the luminary sealed. So you pretty much got this focus on the dust. And we used to select probably from this column or from the Navarro, depending on the environment, some values of the luminary maintenance factor. And we can see it even up to date. Many companies are looking into it. And what you don't really notice is that there is a significant note right there in the bottom saying that the data given in the table is on a typical value, and please, for the specific luminary selected, should obtain from the luminary manufacturer if the manufacturer obviously has got data. So here is a little bit of history. Here's a little bit of history, something that we used to show in 2013. That's almost 8 years ago. You can see in 2013, this is the time that not so many companies were looking into the accurate calculation of the maintenance factor and all these components. Here are the screenshots from our presentations. At the time when we were selling our U7, we were already certain about the Lamp Lumen maintenance factor, but we also were providing the entire maintenance factor, which is obviously a product of a Lamp Lumen maintenance factor, the luminary maintenance factor, lamp survival factor, and room surface maintenance factor. So all these parameters we were really certain about, and these were the numbers that we were obtaining. If it's available, or if it's not available, again, you know, I refer to that particular table from 1680.4 standards. I look into the oil prices as a GST inclusive, because someone's going to pay a GST in the end of the day. So as we're kind of aiming to find out economics of the LEDs, we have to be aware that the end user is going to pay energy prices, and it's all going to hit an end user, and GST is one of the factors. I allow air conditioning impact of 20%. What that means is that if you've got a lighting system which is producing a lot of heat as a waste product, this heat has to be removed from the building. What it means, the air conditioning system has to work harder in order to remove this particular energy, to remove this heat from the building, and that impact is 20%. That means if I'm burning 1 kilowatt of power due to electrical lighting system, you know, 200 watts in addition has to be consumed by my air conditioning system. My apologies, something happened. I base operating hours of annual operating hours 3.5 thousand, annual inflation 2%. Maintain luminous flux are required to achieve around 320 lux. Okay, we're talking about the indoor application. Yeah, we could talk about corridors, we could talk about lobbies, meeting rooms, but let's sort of focus on offices. And offices, they are sort of, you know, designed for 320 lux maintain, and I allow 15% of margin because it's very difficult to get exactly 320 lux. I use the energy price of $0.2. That's a net energy price per kilowatt hours, and CO2 emission, that was based on the factor that it's actually well designed for Victoria, I would say. Victoria maybe is even a little bit worse this time, but around 1 kilogram per kilowatt hour. This is the figure you guys have in Victoria. In New Zealand, it's quarter of that, but over there, obviously, it's a little bit more. And I focus on the duration of the test, 50,000 hours. So here is my first model. First model, a room with 4 luminaries. And I would like to maintain certain luminous flux in the end of the lifetime, which is 50 kilo-hours, I will obviously allow that 15% more of the margin, because it's very difficult to achieve exactly 320 lux. So obviously, you have to be aware that a brand new installation is seriously overpowered. It obviously depends on the manufacturer and the product and so on, but that's the effect what we're talking about. But you want to, in the end of the lifetime, sort of end up somewhere. So in conclusions, I would like to probably say that research on the luminary maintenance factor and lamp lumen maintenance factor should continue. And I'm really glad that we are actually one of the leaders doing this. And we've been doing this as long as LEDs were introduced to the market. And even in 2013, we were already having quite a lot of good knowledge about these products. The CLO drivers, the constant light output drivers, which are intentionally reducing power, and then gradually increasing the power as the luminaires get a little bit older, but do not really offer superior savings, I would say. They're good ideas. They're a little bit clumsy to install, and replacing drivers, it's a problem, but they're not really a golden solution to this problem, in my opinion. Low price luminaires are normally affected by a short lifetime. That's something we have to be aware as engineers. And replacing these luminaires, it's a very, very high cost. Someone has to pay it. Eventually, our clients will be paying for that. And you also have to be aware, if luminaires are to be replaced quite frequently, you're producing a lot of waste. Okay, so it's not only CO2, but metal, plastic, electronics. And final conclusion, that using probably more luminaires of lower power affects the CO2 emissions, statistically speaking. At least statistically speaking, this is the figure of what we can observe. You got the chances of saving a bit more of the CO2 emission. Okay, that will be all.